In this video, I'd like to take you behind the scenes of the McPit and show you how most of the things in it work, any interesting challenges that I faced, and what solutions I was able to come up with. So the majority of the interfaces are GPIOs, so basic switches. They were just purchased either, the more unique ones were purchased from a place called DigiKey, and the ones that I needed more of were purchased through eBay, came from Hong Kong, so they're cheap, but they were cheap. So those are connected to a couple of different kinds of computer interfaces that ultimately just turn them into USB signaling. So soldered from the switch to these controllers, and then a little bit of programming to get those controllers to send the correct signals to the game. One of the controllers that I used is called an X Keys keyboard matrix, and those are suitable for momentary switches, so switches that are closed only while they're being used. There's a few like these guys are only temporarily in those positions and then they release. So those are great candidates for matrix encoders, and they are the cheapest cost per I/O. In order to interface with the matrix, if we go, this is where most of the those leads all end up. That green board on the top is the actual matrix encoder, but to make it more practical to wire it out to all these boards, I made my own breakout board, which is on the left, and we'll zip over to this side to have a slightly better look at it. But it made it so that I could just plug individual switches into my matrix breakout board, and then program it from the computer side. So for the majority of those, every time a switch is closed, it's pre-programmed to send a certain keystroke. So pressing this button might press Control 0, this button might press Alt Enter, etc., etc. The next controller that I worked with is called a Hagstrom USB 108. That's the larger green board along the bottom there. So it's very easy to work with. I was real happy with it, but it is the most expensive of the three solutions. It was a great board to have in a pit, and if you have to start with just one, it's a great choice. It has a variety of inputs, not just general purpose IOs, but it has a spinner interface for the trackball. It has some analog inputs. And it was relatively easy to program. So most of the non-momentary switches are on this side are connected to the USB 108 and translated into joystick buttons that DirectX can recognize. So those are ideal because they provide better synchronization between the game and the position of the switch. So if you start up in pit and a switch is off, it'll immediately be synced. The third type of controller that I went with was an Arduino little mini controller. There's a couple up underneath here that you'll see. They're just floating in space. The reason I first discovered them is because they were an easy way to interface with the displays. When I went to put those live displays right into the panels, I needed a little controller to drive those. And by that point in my pit development, the product DCS BIOS was released, which is a phenomenal product. I would recommend it. If I were doing this again from scratch, I would do it all with these little Arduinos and DCS BIOS. The main advantage of doing it is that you end up with about one controller for every 2 to 3 panels. So everything's a lot more modular and easier to wire up, versus when I ran to my central controllers that are way over here, there are long runs of Cat5 wiring from this panel all the way up around to the main controller. So the Arduino DCS BIOS is a great solution, and it had better support for outputs, including the displays. I think I ended up with 5 or 6 of them in the pit at the end, so I have some tiered USB hubs. One of them is up there in the corner. So that solved all my I/O needs. We'll just go around the pit, and if I see anything that's unique, I'll just mention it. I put some USB breakouts in just to plug in extra things like my TrackIR headset. USB audio device. This isn't supported yet, but the idea is that when I fly multiplayer online, that the team communication will be done through a little USB sound card here to my headset, whereas the game audio will be rendered through some 5.1 speakers with a sub. So that breaks out of this panel. Rotary encoders are very challenging, not so much challenging, but expensive to interface with digital components. And again, the Arduino DCS BIOS gives a great solution to that. So you just need 2 inputs on an Arduino, and his library does a really good job of converting those into up-down signaling. LED outputs, there's a variety around the pit, and those are all done with, the name's escaping me. There's another controller board up here. It's not cheap, but it does a good job of controlling over power situations. So that's up there. Let's see if I can read the name off it. Yes, it's a Fidget LED, P-H-I-D-G-E-T. So another USB device, and that is controlled to LEDs around the pit. No real magic there. So that's where all the static LEDs are coming from. Some of the, this is actually more from the fact that I tried to combine an F16 and an A10 pit. So the F16 has these guards over the manual pitch control system. So these are actually just little fence bolts that looked close enough. So that was kind of fun. I can talk about the assembly of an individual panel. So the process was design the layout of the panel, the position of each switch, what the text is in Microsoft Visio, and then I exported that to a vector file format and sent it off to a laser engraver who pre-cut all these panels, and then depending on the which layer I sent it to him on, it would either be engraved, which would make it appear as white, or cut right through. So when these panels arrived to me, they had all the cutouts in the right position as I had laid them out. So I took those acrylic engraved panels. I had some thin aluminum paneling made up. I went with aluminum because it was easy to work with, very soft, but gave you enough structural integrity to hold the panel in place. So I laminated those together with a 3M double-sided clear adhesive, which is another eBay purchase. And then took them to, I basically have a drill press and a scroll saw and would cut out. The circular holes are easy. The rectangular ones were not as fun, but I didn't have too many of those to do. So that put the holes through the aluminum and then just physically mounted the switches. Most of them are just threaded mounts. Then solder it all on the back, program the controller, and move on to the next panel. So it got pretty repetitive by the end, but each panel had its little unique challenges usually. This 4-way hat ended up coming out of an old CH Pro throttle I had lying around. Some of the panels I didn't implement. Most of the ones that I didn't implement are because they simply aren't implemented in game. They just do nothing, so wasn't a lot of value added there. This is all pretty much repetitive. The fuel receiver handle, which would open the receiver door to receive fuel for an in-air refueling, is a pretty unique shape, and I ended up recreating that using an acrylic molding process, which I bought from a local craft store. Basically I hand molded out of a plasticine the shape that I wanted, and then coated that in some latex to make a reverse cast, then filled that with a 2-part resin, and then once that was dry, just sanded it down and painted it up. So far from perfect, but gives the basic idea. It's not used frequently. This panel was my attempt at making a backlit panel. It was kind of my prototype. It ended up being extremely expensive. This is a silk screening process, and I asked the company to make a sample just so I could test it, but I guess setting up a silk screen, whether it's large or small, is all pretty much the same cost, so not proud to admit that. I think it's the second most expensive thing in this entire cockpit, I'm sad to say, and unfortunately it looked horrible. The black silk screen didn't block very much light at all, so you can see there's an EL wire running behind it, and you could just see where that ran all around. So That was an early fail, but what can I say? I just leave the light off now, and it's usable. I gave up on backlighting the rest of the pit because it was just going to be too expensive. This is I think it's a 14, maybe 15-inch touchscreen that I got out of an old Kodak photo booth, another eBay purchase. So because it's a touchscreen, it allows me to implement some of the pretty much the A10 CDU, which is a full keyboard, and it just would have been way too much work to recreate that in physical form. Plus, in the real plane, it would be located right here, and I needed my trackball in that location. So I have my CDU on a touchscreen, and then I do have a couple other switches that just didn't find a home that I've squeezed onto the touchscreen. And on this side, it's a larger monitor where I just took it was a regular desktop monitor, and I just took the whole bezel off and then mounted it into here. So it's not a touchscreen, but I use it for all my instruments. I originally had my MFCDs mounted over it, which would be a little more authentic, but when I got a new video card, I found out that it was actually realistic to run the game at 4K if I was only outputting the game view onto a single monitor, and that was a price I was willing to pay. So I moved the MFCDs up onto the primary display, and I'm running these two screens on a secondary video card. That's my track IR, so if you're into flight sims, you'll already know about it, but if you don't, if you aren't, it's a head tracking system. So the idea is this is the headset I wear, and it has 3 infrared light emitting diodes, and you calibrate it, and sorry, this side of it is basically a camera. So you calibrate the position of your head in 3D space, and that will synchronize with the position of the pilot's head in the game. That way, if you want to look out over your left wing, you simply turn your head a small amount, and then the pilot's head in game will turn a larger amount. And it's a little bit hard to describe. There's a very small learning curve. It's a little disorienting when you first get into it, but once you get used to it, it's invaluable. It solves the need to have 3 displays or a huge parabolic screen. Once you get used to the system, it really feels like you're in the world, and you can look around as you need to. Other fun stories. Most of that is pretty much just lather, rinse, repeat so far. This is the Thrustmaster Warthog, so it is a retail product, extremely well built. It's expensive, but if you're into flying, it would be, if you were starting from scratch, I would recommend the Track IR first, and then a Warthog would be your second investment. Even if you're not flying the A10, there's lots of programmable switches all around it. Very well built. So I'm extremely happy with it. The trackball, I think I mentioned a few times, out of an old Golden Tee machine. This switch is kind of fun. So it controls the emergency floodlight. It's a dual pole, so I actually have it wired up to a LED cabinet light that was left over from my kitchen renovation project. So when I flick it, it turns the physical light on and off, but it's also connected to one of the USB controllers in game, so you get the same lighting effect in the pit, in the virtual pit, as you do in the physical pit with just a single switch. This is the power switch for the actual PC, so part of my pre-flight is to turn on the PC by running, by just flicking this one. The chair itself has some controls. I think you're going to go upside down here, I apologize. This is a trailer latch from Princess Auto that I wired a switch to, so it's my eject lever, and then I also have my seat, the ejection seat armed is a switch baked into the side of this, and then those are wired to the physical pit with just a DB9 cable that runs along the floor. The rudder pedals are the Cytec Pro Flight. Shout out to my buddy who helped me get a great deal on those. They work very well. They're not top of the line by any stretch, but it's your rudder. It's not that important, so happy with those as well. The flight display, I guess I skipped. That's a 39-inch 4K display. It's only capable of rendering 30 frames a second, but I haven't even noticed that, to be totally honest. and flying at 4K is just incomparable. The detail you can get at distance is dramatically better than a 1080p. This is a piece of just acrylic clear plastic that I mounted. I was struggling recording coordinates fast enough in some of the missions, and reading from an RAF pilot who wrote about his A10 experience, I guess what they would do is they'd have a wax pencil, and as coordinates were called out, they'd write them on the canopy glass. So I installed this to kind of emulate that. So with my knee board, I have just a whiteboard marker records on it quite well, so I can just write down coordinates as they're called out, and then enter them into the computer with a little more care after that. Can't think of anything else to mention, so that's pretty much the overview. Feel free to post questions below. I can talk about this stuff all day, so if there's more detail required on any part of this, let me know. And I'm also quite active on the Eagle Dynamics forums for the DCS products, so you can find me there as well. Thanks for watching.